So my point is that in a beta decay, in a beta decay, the protons decreases, the protons increases, and the neutrons decreases. But the mass number remains the same. Yes or no?
Yes.
The mass number remains the same. That's the beta decay. So now let's start with X element, which was atomic number 90 and 234. And I hope you remember that, when a beta decay took place. So these are 90 protons and these were protons plus neutrons, 234 here at the top.
Mhm.
So here, if beta decay is taking place, so you know that, one neutron would break down. So the element Y would be formed. The mass number shall be 234. And here it is going to become 91 protons. How do we understand this? So we have to subtract, right? Because something is coming out of the nucleus. So can you just understand that 234 minus 0 is nothing but 234 only?
Mhm.
And 90 minus of minus 1, this becomes plus. So this becomes 91. Yes or no?
Yes.
And again, a beta decay takes place. So it shall be what? There will be Z. So 91 minus of minus 1 shall become 92. And 234 minus 0 shall become 234.
Mhm.
So what am I trying to tell you? That, every time a beta decay takes place, the new element so formed, will have a different number of protons. 90 protons, and now will be 91 protons. But the mass number shall remain the same.
Mhm.
Yes or no?
Yeah.
And when we have two elements, having same mass number, but different atomic numbers, so they are called as isobars.
Yes.
So I would say every beta decay produces an isobar. Every beta decay produces
Yes. Okay.
isobars. Are you understanding my point?
Yeah.
Okay. So when we are talking about the beta decay, just understand that beta decay produces isobars. And what are isobars? These are the atoms of two different elements. You understand? The atomic
Yes.
number is different. So definitely 90 atomic number is something, 91 atomic number is something else.
Yes, but the 234 is the same, so
So when the mass is same, we say it is isobar.
yes.
What is the definition of isobar? Atoms of different element. Atoms of different element
Mhm.
having a different atomic numbers, but same mass number.
Mhm.
But same mass numbers. So that shall be my concept of atomic isobars,
Yes.
right? And now just have a look now. When both alpha decay and beta decay occur at the same pace. Now, when I'm saying that, we have uranium 92 to 38. Okay.
Mhm.
Now, not just 92 uranium to 38. Let me take some other example. Let's suppose I take an example of thorium 90 and 256. And let's suppose it undergoes alpha decay. Alpha decay is what? 2,4. 2,4 means from the nucleus of thorium, we had 90 protons, and we know that 256 was equals to protons plus neutrons. So protons was 90 in this nucleus, and neutrons we had to find out, isn't it? That this number represents the number of protons.
Mhm.
So if you subtract 90 from 256, the neutrons I will be getting as 6, and then I'll get 6 again, and then I'll get 1. Yes or no?
Mm-hmm.
So I will have 166 neutrons, and from here a set of 2 protons and 2 neutrons shall leave, which is my helium nucleus. So I will have a new nucleus being formed, and that new nucleus will have 88 protons and 164 neutrons. So basically, an alpha decay leading to decrease in protons and decrease in neutrons. And now, let's suppose some X element shall be formed. That X element will have 88 mass number, and that shall have 252 as the mass number. So atomic number shall become 88 and mass number shall become 252. Yes or no?
Mm-hmm.
It again undergoes one beta decay. So what is one beta decay? What is one beta decay? That one neutron shall break down. So I will have now 163 neutrons left, and that will produce one proton and one electron. And the
Neutron. Yes.
electrons cannot stay inside the nucleus. A very big statement. Electrons
No.
cannot stay inside the nucleus.
Mm-hmm.
So when electrons cannot stay inside the nucleus, what do you think would mean? Tell me. So here the protons have increased now. So now in whatever Y element that is being formed, there would be 89 protons. But since one neutron has decreased and one proton has increased, so P plus N, there is no change now. You can add it up also, 89 plus 163. So again it adds up to 252 only. Now again you undergo a beta decay. Two beta decays we have to do. What am I trying to show you? Just have a look. So some Z element shall be formed. And in that Z element, what exactly is happening? 89 minus of minus 1. Why? Because when the new nucleus is being formed, it had 89 protons and 163 neutrons. So that was why. Now again one neutron breaks. So I will be left with 162 neutrons. And that one neutron shall break into proton plus electron. That electron will again come out.
Mm-hmm.
So again the new proton number shall be 90 protons and 162 neutrons. So I will have 90 protons and 252 shall be the number now.
Okay.
Now just have a look at the first element and the last element. The protons are the same. So that means one alpha decay and two beta decays leads to the formation of two elements. And when protons are the same, that means what? You understand? When atomic number is same, it is definitely the same element, which is thorium.
Yes.
Yeah. Atomic number is actually the characteristic. So 90 protons is nothing but thorium.
Right.
That means thorium is again formed, but a different atom of thorium is formed whose mass is little lighter. Do you understand my point? What am I trying to tell you? That now one alpha decay and two beta decays leads to the formation of isotopes. And what are isotopes? Isotopes are the atoms of same element, are the atoms of same element having same atomic number but different mass numbers. So it's like this, that when you look for carbon in nature, all the atoms of carbon are there, but some are heavier atoms of carbon and some are lighter elements of carbon, some are lighter atoms of carbon. And why is that so? Because carbon atomic number is 6, so all of them will contain 6 protons. But some carbon nucleus consists of 6 neutrons. Some carbon nucleus consists of 8 neutrons. So the one which consists of 8 neutrons, the overall mass becomes 14. And where the neutrons are 6, the overall mass becomes 12. So we can
Okay.
say that, in nature, we have two different types of carbon atoms, one heavier nucleus and one lighter nucleus. But they are both carbon. The characteristic shall that they are going to depict, that the characteristic that they're going to portray would be of carbon only, chemically also.
Mm-hmm.
But the mass wise, the physical weight, one would be heavier, one would be lighter. So it is
Mm-hmm.
a possibility that in nature, if you talk about sodium, it's not necessary that every sodium element is going to be having 11 protons and 23 neutrons. No, it would have what? It would definitely have 11 protons, no doubt. But there might be some other sodium element which would contain 11 protons, but maybe 13 neutrons. And just because of the presence of one extra neutron, that would act as a different sodium, a heavier sodium atom, but a sodium atom. You understand my point?
Mm-hmm.
What I'm trying to explain you here is that, this is a sort of, what do you call, these are called isotopes having same atomic number, same atomic number. What is atomic number? The number of protons,
Photons.
but different mass numbers. I hope you're understanding. Yes or no?
Mm-hmm.
Yes or no?
Yes.
Right? So that is the concept.
Okay.
Right? One second. Right? So this is how basically this is going to work.
Mm-hmm.
So now what can I conclude from here? That alpha decay followed by two beta decays produces isotopes, and every beta decay produces isobars. What is isobar? Bar basically means mass, and iso means same. So the atoms having same masses, but they could be of different elements.
Yes.
You understand? So atoms of
Mm-hmm.
atoms of different elements, but having different atomic numbers, but same mass.